351. All right, number 8, we are given 2 points, 0, 3, and 5/3, -1/2. And we're asked if, in fact, they are solutions to a given problem. So the 2 possible answers, 0, 3, that's 1 point. And the other one, the ugly one, 5/3, common, -1/2. Those are our 2 possible solutions. And our equation is 3m minus 2n equals 6. Hey, we don't have an x and a y, but we have an m and an n. I said if you have different letters, we just go alphabetical. We go alphabetical. That means the first one is m and the second one is n. Now it's just plug and chug and see if it's true or false. First one's pretty easy. 3 times 0, that's 0. Minus 2 times 3 is -6. And clearly that doesn't work. So nope. See what I did?
So it gives you possible solutions. You have to see if it works.
Yeah. Second one, okay, ugly fractions, but look, denominator 3, denominator 2. You're going to see that they cancel, become nice friendly numbers here when you do it. So we got 3 times m, which is 5/2, minus 2 times -1/2. And we're told does that equal 6. Why did I write a 2 when I meant to write a 3? All right, there we go. 3's cancel, and you're left with 5. Minus, the 2's cancel, negative and a negative. Right? 5 plus 1 is 6. That one works. Check. No, yes. All right. Ready to grade? All right. If you have nothing written on your paper right now, don't even think about turning it in. If all you have are yeses and nos and there's no work, then you didn't do the work. All right. Was it 1 through 12? Oh, here we go. I'm going to do this quickly. It's no, yes, yes, no, that sort of thing. Number 1 is yes, yes. Number 2 is no, yes. Number 3 is yes, no. Number 4 is yes, no. Number 5 is yes, yes. Number 6 is no, yes. Number 7 is yes, yes. Number 8, we just did it, no, yes. Number 9, no, no. Number 10 is no, no. Number 11 is no, yes. And number 12 is yes, yes. If you turn this in without work, I know you didn't do it.
Yeah, you didn't copy the answer.
Right.
I'm just copying when I actually do it.
I know.
All right.
All right, can I?
Yes, please.
Is that the?
This is the. All right. Today is an easy day. It is not. I mean, the challenging stuff. I wouldn't say any of it's that challenging. Most of this chapter is a repeat of what you learned in pre-algebra. If you had me for pre-algebra, we did this last year.
Graphing.
If you did not have me, it kind of depends on, what you learned in pre-algebra last year. But for the most part, linear equations should be something that you're somewhat familiar with. All right, let's take a look at the calendar. We're going to do 8-2 today, 8-4. There's a whole lot going on with 8-4. I break it up into 3 days, nice, manageable, bite-sized pieces. Then we'll do a mini review because I want to make sure you pass the quiz. Scatter plots is not an entire section here. It's an extra additional thing, but scatter plots is something you need to know in Algebra 1. Long story short, we'll take chapter test next Friday. Here's your homework. Copy it down. Now, the question is going to be, do I need graph paper to do this? The answer is sure if you have it. It's not a requirement. If you're a very sloppy person, you're probably going to want to have graph paper. If you're not a sloppy person, this can be done quickly without graph paper. Yeah, if you have graph paper, it will make your life a little easier. It was on the required stuff that you're supposed to have for class.
Some in my, can I go get some from my locker?
Well, you don't need it right now.
But I want to do.
Okay.
Then you need it right now.
Let me write this in.
Huh?
Go grab yourself a sheet from the cat.
Oh my gosh, it's attached.
All right. Okay, did you guys do linear equations last year in pre-algebra? Like you graph lines.
Yeah, we do.
Okay.
Okay.
Wait, did we do this last
This is the table of pain.
Oh.
Oh no! Stop! Don't you mention that name.
Table of pain.
All right.
Hey, don't.
I call it the table of pain because it's just a lot of calculations. But
Table.
you're in Algebra 1. Very quickly after this class, we transition from the table of pain to the I hate you, Mr. C, for not showing me this last year. And the reason why you don't get showed this in pre-algebra is because it's a much higher level skill. It's based upon the fact that the table of pain works. It's kind of like magic the way it eventually works, but you have to know how to do a table of pain first before we can teach you the magic. All right, points, lines, and their graphs. So if there's a class that I really shouldn't have to teach, it's this one, but I do know occasionally I'll get some kids that have never graphed a linear equation. They've graphed points, but maybe not a linear equation. Graphing points. If I ask you to put 3 on a number line, not a 9th grade task, well, clearly I need there's my number line, and then I need to put 3 on it. So how do you do that? I mean, how do we graph 3 on the number line? What? Where do you want me to put the dot?
On 3.
Above it, below it, or on it?
On it. On it.
Thank you. You had a good teacher, because occasionally I will get kids, when I ask to do this, the dot will appear above or below it.
That's nasty.
I have no idea why they do that.
That's way more messy.
The dot goes on the number line. Okay, so that's a 6th grade task, right? We're going to be graphing points today, one of the things. So first off, write this definition down. Box number 1. So a point is just a position in space. Now, the first thing to wrap your head around is that we live in space, not outer space, but we live in space. I am walking through space right now. If I want to talk about a specific location, watch me, right here, that is a position. If I step away from it, it's still there. So even though we were going to be graphing a physical object, a circle filled in, we're not talking about the shape, we're talking about the position. I give this classical demonstration. I'm not going to hit you or hurt you. I give this classical demonstration about his head and my fist, right? Right? For me to hurt him, my fist would have to occupy the same space, finish the sentence, as his face, right? And I already told you I wasn't going to hurt you or hurt you. So, no, I'm not going to hit anybody. But that's the idea of space and location, okay?
Punching people, that's the idea.
Well, it's very clear to you, it's memorable, you remember it. But what I don't want you to think about is that we're going to graph these things called points. It's not a circle, it's just a location. It's like an address.
Didn't we do this
Right?
last year?
We did exactly the same thing last year. All right. Yes, we will draw a shape, but that shape has no size. It's not a triangle, it's not a circle, it's just a location. But we got to put a dot there to indicate where that space is. Okay. We usually use a dot, but you can use a triangle. You can use a picture of a cat if you wanted to. But that would take a long time to graph 5 points if you're drawing pictures of cats for each one. So we usually just put a single circle that's filled in, a dot. Okay. In 2D space, which is this year, 2D, 2 dimensions, that means flat, left, right, up, and down. We represent points by what's called an ordered pair. An x coordinate and a y coordinate, and its name. We name points, if you remember from pre-algebra last year, by a capital letter A. Okay? It will have 2 numbers separated by a comma. That could be any number, positive, negative, fractions, square roots, anything. Even formulas can go in here, right? But the first thing is how far are you left and right. The second one is how far are you up and down. Should be straight reviews. Like this shouldn't be the first time you've ever graphed points. This is the dude responsible for all your pain, right here. Direct your hatred to Rene Descartes. He is the guy that joined 2 maths together. Geometry, we've had that since the Greeks, right? Algebra, we've had that since the Iranians came up with algebra, right? He's the guy that said, hey, these are actually the same thing. Geometry is the same as algebra, algebra is the same as geometry, or that we can combine the 2. He's responsible. He's the guy that came up with this thing that we're about to use.
When I die,
by the way, this was not a way back when. They did not have this until the late 16th century. I forget the actual year he came up with it, but it was 16 something. He's also the guy you probably heard the saying, I think, therefore I am. He's French. He's the guy that came up with this. And he has a cool mustache. All right. So he combined both a left and a right. He called it the x-axis, and he combined an up and down number line. And this is what joined algebra and geometry. You'll see why here in a second. Okay, so if we were to graph the point 2, 3, hopefully this is not the first time you've ever graphed. Where's my point? X, Y, 2, 3. Okay. All right, so this is called the coordinate plane, box 2. Draw that real quick. Don't put the whole square, just put big plus symbol.
Oh my gosh.
Big plus symbol. The left and right is your x-axis. Yeah, just briefly, just box 2. This is your x, and this is your y. Now, I can't guarantee you that every single time I hand you something that already has a graph, it will have an x and a y on it. But I try to do that just so that you have the chance of getting everything correct. If you're doing this on graph paper and you put the big plus symbol, make sure you label x and y. You don't have to put numbers ever. Right? Don't waste your time. I mean, I have kids that literally will spend 5 minutes trying to recreate this. The heck with that. You can count little tick marks. Right? You don't need to put any numbers. Numbers are great. They help. It makes it look pretty, but you don't have to put numbers. What you do need to know is we're understanding things called quadrants. If you put the big plus symbol, it's pretty clear that you got 1, 2, 3, 4 quadrants. His name is René Descartes. Des means from or of the city of Cartes, I think. And Carte starts with the letter C. I'm Mr. C. There's a C. And if you ever wonder with the quadrants, you just make a big capital letter C. 1, 2, 3, 4. Okay?
Shouldn't it be the 2 and the 1 swap? 1, 2.
It doesn't. Now, the reason they chose this to be quadrant number 1 is because everything is positive in quadrant 1.
And
Right.
quadrant,
Quadrant 3, everything's negative.
So then why don't you put the even number in quadrant 1 too?
Well, remember, it's made up of 2 number lines. The left and right number line, the negatives are to the left, the positives are right. But on the vertical one, positives are above, negatives are below, and it just happens, it works out that way. So 1, 2, 3, 4 for your quadrants. Quadrants are also in Roman numerals for some strange reason. Okay. Did anybody remember the center is called the
Origin.
origin? Here we go. That's everything we need to know.
Orange.
Graphing points, not a 9th grade thing. Once again, they will give you a point A, and ask you to graph it. If you still need to do this, then still do this. Like label it X, Y, so you don't screw it up. If you don't, like, why would I do that? I know where 2, 3 is, then go for it. 2 tells you how far to go left and right. The 3 tells you how far to go up and down. So it says go to 2 on the X number line. That's right here, right? That's right there. Anything along that red line is the X value 2, right? Anything along that red line is the X value 2. The second one is your Y value. It's a positive 3. Well, here's Y. Positive 3 is right here. So anywhere along that blue line is a Y value of positive 3. Where the red line and the blue line intersect, well, that's 2, 3. Now, is that how you actually graph? Oh, heck no. How do you graph? You graph by starting at the origin and doing what? You go to positive 2, and then I go up 3. I mean, that's how you actually graph. If you're just graphing 1 point or maybe 2 points, you label them. Graphing lines, you're not going to label your points. By the way, we're going to be we're going to be graphing lines today.
See, look, I did it.
So B is at 6, 3. So I need to go to 6 on the x-axis. 6 on the x-axis is 1 over here, right? I go 6 over, and then 3 up. 1, 2, 3. I'm right there. Who has never graphed a point before? I don't want to spend too much time on this. Aiden, you comfortable doing this? Chris? Piper? Who else did I not have? You done this before? Julie? You done this before? Harley? Okay, enough of that. They're going to ask you to graph some points. The messy ones, when does it become hard or challenging? I call it the messy ones. When are you going to screw this up?
It's negative.
When there's negatives or when there's a... No, you don't ever screw with positives. Everybody gets that right. You screwed up when one of them is negative or both of them are negative. Hey, this is your x and that's your y. This means on the x value, go to not positive 6,
Go back to 6.
negative 6. And then I got to go to positive 3. So 3 up from there, I'm right there. Okay. So that's your first messy one when there's negatives. Kids will always mess this up. It doesn't matter whether they're calculus students or algebra students. You can mess this up if you're not careful. The other messy one, anybody know?
If the second one's negative.
Turns out when there's zeros involved.
Oh, that's not that hard.
For some reason, people mess this up all the time. How far are we going left or right on this one?
What does horizontal mean? Which way is that?
We'll talk about that in a second. We're not going anywhere left and right. So we stay on the origin and then we go up 3.
People mess up.
Well, they'll put it right smack here. They'll say that's 0, 3. Why? Because they didn't go up or down any. They'll transpose the 0 to the y, right? Just be careful when there's zeros or there's negatives involved. All right. Just make me happy and graph these, please. Label them. We'll find out here in a second. And then check your work with my work. Did you do it right?
Yeah.
Okay. All right. I had to get that out of the way because all the rest that we do is dependent upon your ability to graph points. And graphing points is 7th and 8th grade standards. Our standard, Algebra 1, is you got to graph linear equation. All right. So where we're going with this, we're going to be graphing lines today. From the last class, Friday, what did we do? What did we do on Friday? No. What did we do on Friday? That we just turned in homework for. What was it though?
It was like they used the coordinates.
We did no graphing on Friday. Something about x and y, right? I gave you an equation that had an x and a y. What did you do?
Solve.
You plugged numbers in for x and you saw what y was. Or you plugged something for x and y and saw if it was true. Okay? That's what we're doing today. We're just going to take it to the logical conclusion, which is this. Okay? If I plug a 1 for x in here, what do we get for y? Plug a 1 in. What do you get for y? We get 4. Okay? We plug a 1 in, we get a 4. What happens if we plug a 2 in? We get 3. What happens if we plug a 0 in? What happens if we plug a negative 3? Is anyone lost on how everyone else in the class quickly did that? Okay, now that's an easy one, right? This is what we did on Friday, or we found if this makes it true or false. Well, what's the logical step now that I have all these points? What would be the next logical step? Okay, great, you found points. Now what? Say it. Let's graph the points and see what it makes. So you take what you did on Friday, this, and you graph those points. So it turns out that when you graph them, it actually makes a line.
Wow.
So what is this called? Why is it called a linear equation? Because it makes a line, literally.
Oh, so that's what we're doing?
When you graph this equation, it makes a line. That's why we call it a linear equation. Equations with 2
On
variables
the homework, it gave
make
you-
lines. What?
Or on the homework, it gave you.
Well, how about we wait for the whole class and I'll get there. So tonight for homework, they're going to give you an equation. You're going to have to graph that equation. So let's write this down, box 4. What? Okay, I'll get it. Write this down, box 4. Linear equations. These are equations that form lines when you graph them. We will spend 2 chapters on this.
Why?
And then we'll get to equations that don't make lines.
It's just the same thing. Or is it like?
You'll see. You'll see. The second thing, okay, welcome to Algebra 1. You didn't get this last year. This is a long definition. So if you take one of those equations that's written with 2 variables, x and y, and you put a number in front of the x and the y, and you put the x and the y on the left side, and you put the other number on the right side, so it looks like this. AX plus BY equals C. We call this form, you're going to get many forms of this. Here's your first one. This is called standard form. So all we're saying is we're taking that linear equation, we're putting x and y on the left side, we're putting the other number, the number all by itself, it's called the constant, on the right side, and there's one extra caveat that we have to add. First off, A, B, and C are all integers, no fractions, no decimals allowed. Like, well, how could I could have a fraction? Yeah, we clear the fraction. If it's a decimal, we clear the decimal. But A, B, and C are all going to be integers, friendly numbers. Further, A can be 0, B can be 0, C can be 0, but A and B cannot both be 0. That's what this, and if that's the case, you have it in standard form. We're going to get 3 forms this year: standard form, slope-intercept form, point-slope form. This is why this chapter becomes challenging towards the end, but right now it's not. So linear equation, any equation that makes a line when you graph it. If that linear equation looks like this, now A and B and C are all going to be numbers, integers. So maybe it's 2x plus 3y equals 5. But if it's in that form, we call it, hey, it's in standard form. Algebra 1 does a bad job with standard form. Algebra 2 does a much better job. You kind of use it a bit more in standard form. This year, we just say, hey, look, it's in standard form. And you're like, so what? When you get to Algebra 2, you get a so what for standard form. This year, not so much. Okay, does everybody have those 2 definitions now? All right, so hey, is this in standard form? Are x and y on the left side? Is the other number on the other side? Are all the numbers integers? Yes. Now, it doesn't say anything about positive or negative. It just says that A and B cannot both be 0. One of them could be 0, but they're not both 0. Everything's an integer. Good to go, standard form. So in this chapter, it's all about graphing lines. Okay, I'm going to give you an equation. You graph a line. I give you that sucker tonight for homework, right? Here's the thing that's different from last year. If I give you 1 point, you see that point? How many lines, stay with me, how many lines can I draw through that 1 point?
Unlimited.
Well, there's 1. Can I draw another one?
Yes.
Can I draw another one? How many lines?
All of the infinity.
Infinite number of lines. Watch what happens if I put 2 points. Now, I'm talking lines, not curves. How many lines can you draw through those 2 points?
No.
So when you're graphing a line, last year I made you do how many points? Do you remember from table of pain? I'm sure your teacher did the same thing.
3.
I made you start off doing 4, and then we broke it down to 3. This year, because you're in Algebra 1, how many points to find a line? So this year you get to graph 2 points. Here's the only problem with 2 points. If one of them is screwed up, you always get a line. If instead of graphing the right point, you graph it right here, guess what? You get a line and it's the wrong line. So why last year did I make you graph 3 points? Because if this one is wrong, well, then you can tell you didn't make a line. So although I'm going to absolutely 100% say, yeah, you just need 2 points, I'm going to always encourage you to graph 3 points. Okay? But certainly you can do this with 2 points. So all we need to do is graph 2 points, play connect the dots, we're done. We graph a 3rd point, we confirm that we're doing it correct. So box 5, let's do one together. Here we go. Hey, it says graph this line right here. Is that standard form? They're going to be in standard form tonight. Okay? So we need to graph this line. We need 2 points. Make your life easy. You remember this from your teacher last year. Pick numbers that are easy. What's the easiest number to pick, Rowan? Mathematically speaking. What's even easier than 1? That's a good one. 0. This is why your teacher told you probably always pick 0. It's not because there's something special about 0 in terms of the line. It's just easy to do the math. So tonight for homework, every time you're going to pick 0. Why? Because it makes your life easy. So we're going to find 1 point. This is step number 1. I don't have you write down the steps. We're just going to do it. So we're going to take this equation, just like we did on Friday. We're going to plug in 0 for x, not for y, but for x. Hey, let's plug in 0 for x. What do you get? 2 times 0. So we're left with negative 3y is equal to 6. All right? You ever see what I'm doing? Can you solve that real quick? Therefore, y equals not 2. What's attached to y? How's attached to the inverse? Y equals negative 2. Are we good on that? All I did was divide both sides by negative 3. Hey, now look. This says when x is 0, y is, there's your first point. 0, negative, that's your x and your y. So I'm writing that as an ordered pair. You see that? I got one of 2 points that I need in order to graph my line.
And then do 1.
What's the next easiest number to work with?
1.
So pick 1.
Wow.
Right? Find another point. Now we can pick 10 if we wanted to, but why mess around with 10 when you can mess around with 1? Or I didn't pick 1, guess what I picked?
0.
But I let y be 0.
Ah.
So you can let x be 1, this will still work, or you can even make your life even easier and let y be 0. You see the logic behind that? If we pick
Yeah.
0, it's gonna be reading
Why
easier.
didn't we do this last year?
We did this last year, but I had you only pick x values, not y values.
Why didn't we pick Y value?
We're gonna see why here in another class. All right, pun intended. All right, so let's let y be 0. 2x minus 3 times 0 equals 6. Negative 3 times 0 is
0.
poof, it goes away. Solve the equation.
3 equals X.
So now here's where the only thing, and this is why we don't do this last year, because kids will just get it backwards. This doesn't say when x is 0, y is 3. It says when x is 3. Can you handle that? The fact that we went yx instead of xy? So when I write the point, what do I write? This is a point right here. When I write the point, what am I going to write? The format is always xy. The format is always xy. So it's 3, 0. 4 or 5 slides ago, I said which one are the messy ones? The ones that have a negative and the ones that have a. This is also why we don't have pre-algebra kids do this, because it involves zeros. Kids are probably going to mess it up. You are finding what are called the intercepts. Yes. First or second? What's 3 times 0? 0. Goes away. So you're just left with 2x equals 6. Divide both sides by 2. Okay. The only issue is you got to remember it goes xy, not yx. Because we want to make our life easy, we pick the easiest number out there, 0. How did I know to pick 0? Because I want the math to be easy. You okay? All right. I got 2 points. Guess what the next step is? Graph and play connect the dots. Do it. Now, here's the only issue. If you graph 2 points, you will always get a line. You just may have the wrong line if you've done something wrong. If you graph a third point, which I'll do at the end here, you'll find out whether it's right or wrong. All right. So there's 0, negative 2. There's 3, 0. Yeah, I made a nice line. I'm not guaranteed unless I pick, I don't know, another number.
2.
Well, how about we let x be, I don't know, 3.
Why wouldn't you just do 1?
Well, I know this is a 6 right here. Well, 1, I'm going to get a fraction.
Oh,
I'm going to pick 3. What's 2 times 3?
6.
Subtract 6 from both sides. That turns into 0. I get negative 3y equals 0. Therefore, y equals 0. And I get 3, 0, which was that right there. Hey, look. That worked out really well. And that's what the point we're trying to get to. So I just confirmed that, in fact, I did get the right.
Wait, so if you get the same point as the last one, you know you did it right?
Well, if I chose that instead of that. Before I chose 0 for y. Now, if I choose 3 for x, I better get 0.
Okay.
Otherwise, I mess something up.
Yeah.
Questions on what I just did? These are called finding the intercepts. The line goes through X right here. That's why this point's called the X-intercept, and this point is called the
Y-intercept.
intercepts are found when you let 0 appear for the X and you let 0 appear for the Y's. Okay? This is a standard technique for graphing
That's
linear
the whole
equations
class.
by hand. All right, example number 2. Not in standard form, still works. Not in standard form, still works. Find one point. What do you want to pick?
X equals 0.
X equals 0. It's the easiest one. So if I plug in 0 for X, negative 2 times 0 is negative 0. So we get Y is equal to
4,
So what is the point?
0, 4.
This is where, for those of you that are lost, you stop me around. Wake up. Tap 'em. This is where, if you're lost, you stop me. You say, I'm lost. I have no idea what you're doing. If you do know what I'm doing, that's fine. Didn't say today was complicated, but it's not. Okay, we got 1 point. We need another point. So this time we're going to let Y be 0. If Y is 0, I mean, literally, we're just going to make 0 for Y. We got to solve that sucker. All right. Subtract 4 from both sides. Last step, divide both sides by X equals 2.
So it would be positive 2.
It would be, because a negative divided by a negative is positive. So we get the point 2 comma 0. If there's only one thing you got to remember it always goes X, Y, not Y, X. So 2 comma 0. Yeah. There's my 2 points. Graph those suckers. Play connect the dots. 0, 4, 2, 0. Connect the dots. All right. Is this what we're doing? Yeah, this is it. Except for one thing I gotta add.
You always say it's it, but then you add on something.
You're a bit
else.
too young, but there was a dude named Steve Jobs.
Yeah.
I know.
You know who he was?
He's trash at life.
And if you ever, he's probably one of the best presenters ever. And he always did one famous thing, is at the very end, he would always say, oh, by the way, there's one last thing.
And then they
And then he would say, iPhone. And they'll go, oh. They would go crazy, right? So a lot of presenters, myself included, have kind of adopted the Jobs model of, oh, one last thing. All right. Okay, one last thing. And this is what Josie was trying to get me to
Did
say.
it again.
Well, that's how I roll. All right. By the way, are we okay with this? Could you do this by yourself tonight for homework?
I don't like being alone.
All right. Tonight for homework, pick zeros. If 0 gives you an ugly number, pick 1. If 1, pick 2. You can pick any number you'd like. Just be careful. Sometimes when you pick different numbers, you can get fractions. You can graph fractions, right? It still works, but you get fractions as an answer. All right. The last thing is, well, we call these special case lines. I mean, most lines look like this, or they look like this, but there's 2 special ones, Chris.
Parallel.
Which line? Not 2 lines, 1 line.
Horizontal.
Horizontal and,
Vertical.
all right. Who does not know what the horizon is? If I ask you to look at the horizon, literally, where am I asking you to look?
Just look
Sky.
to the west.
I'm not asking you to look at the sky.
Just look straight ahead.
I'm not asking you to do, well, that is true. But what am I asking you to look? Like, where is the horizon?
It's the place where the sky meets the ground.
It's the place where the sky meets the ground,
Antarctica.
right? Now, if we take this to the true thing, well, the Earth is round, so the horizon is actually like that.
It's actually.
But to us, it looks like a straight line. Like, we don't see the curve. You'd have to be high up in an airplane to see the curvature of the Earth. We
No.
can't see far enough left and right to see that the Earth is curved. So when I ask you to look at the horizon, for those of you that still screw up horizontal and vertical, horizontal is the word horizon. You're looking at the line that goes left to right. Vertical is up and down. Okay? All right. So the special case ones are vertical and horizontal lines, as Chris said. Okay. Is that vertical? Red one. Vertical or horizontal?
Vertical.
Okay. I'm going to pick a couple points here. I'm gonna pick that point. There's nothing special about these points. That one, that's 3, 4. That one, that's 3, 0. And this one is 1, 2, 3, 1, 2, 3, 4, 3, -4. I picked 3 points. Now, put your thinking brain turned on. Look at all these points in blue. Tell me what you see they have in common.
They're lines.
They all have a 3. And if we were to write underneath them X, Y, so what do they all have in common?
The X is 3.
Any vertical line will have the X's in common. In fact, I don't even care about the Y. It's a vertical line. All I need to know is where does it cross the x-axis? Guess where it crosses the x-axis?
Trace.
That number, because that number never changes. Every point's going to be 3 something, 3 something, 3 something. So here comes the first hard thing in Algebra 1 that you will screw up left and right. How do you define a vertical line, therefore? No. The
Infinite.
paradox or the irony of a vertical line is
Also,
this is the x-axis. The x-axis goes left and right. The y-axis goes up and down. But we just found it's not the y's that they have in common. This is a problem because you see the x and you're thinking left and right. It turns out this is the equation of a vertical line, this vertical line. Any, write this down, please, box 7. Any vertical or all vertical lines are of the form x equals a number. K just represents a number, any real number. Why is this a problem? Because what does it say right there?
X.
And when you think x, you're not thinking up and down, you're thinking left and right. So you're thinking horizontal. It's the opposite of what you would think. I have no problem kids identifying where the things cross an x or y axis. But I will have a kid write that this is y equals 3. Because they're thinking y, well, that goes up and down. But all vertical lines are of the form, stop. All vertical lines are the form of x equals the number. And what's the number? The number is where does it cross the x-axis? Hence the term x equals k. Who's lost on that? Find where your vertical line crosses the x-axis, whatever that number is, goes right there, you're done. Okay, if that's it for vertical lines, finish the sentence.
Horizontal.
So what's the form of a horizontal line? If this is the form of a vertical line, what's the form of a horizontal line? Somebody said it.
Michael said.
Let me prove it to you. Hey, horizontal line, yes? Boys, the part about the F's,
Yes.
I don't have an F, so.
All right. Part about you're going to pay attention? Okay. Doesn't look like it to me. I'm going to pick just a couple random points on the horizontal line. What do you notice?
They're all.
What are 3s? The X's
Ys.
or the Y's? In this case, once again, what they have in common is not the X's, but the Y's. Once again, where this crosses the y-axis, right here, is the how you name the line. If horizontal lines or vertical lines are the form of x equals k, I said that backwards. If vertical lines are the form of x equals k, then horizontal lines are the form of y equals k, box 8. Boy, do kids make a mistake on this. They will flip-flop these left and right.
How did you go from 8 to 11?
No idea. Clearly that's wrong. Okay. Vertical lines, x equals k. Horizontal lines, y. Don't get hung up on this k. It just means a number.
vertical lines.
For me, I mean, I did this now. I figured it out. Now it's one. I just say, well, I just got. Every time I see a vertical horizontal line, I just think opposite. Because I really do for horizontal lines want to write x equals. It's not. It's y equals. Tonight for homework, they'll have you graph some horizontal and vertical lines. You don't have to plug in any numbers. Why? Nothing changes on a horizontal line. You already know what it looks like. You just need to figure out where it intersects the y-axis When it intersects at 3, you're done. Watch how easy this is. Ready? This is box 9. Yours is labeled 11. Sorry. All right. Watch this. What's that say?
X equals 3.
Is that vertical or horizontal?
Horizontal.
See what I mean?
Wait a
I
minute.
got at least 3 people say horizontal.
Well, no, because not
It's-
all the
It's
X's are
opposite of what you would think.
What?
X goes left and right, but X equals is vertical.
I'm now lost.
Okay, I'm also confused.
It's just opposite of what you would think. This says
Okay.
find X equals 3. Where does X equal 3? Well, what is it? A vertical or horizontal line? So I draw a vertical line and I'm done. Now think about this point right here. This is the point
Oh,
3 something. Think about this point. This is the point 3 something, 3 something, 3 something, 3 something, 3. The X's are always 3. That's why X equals is a vertical line. So how do you graph it? You simply find where X equals 3 and draw a vertical line. But you got to know that it's vertical. Generally speaking, the kid that isn't paying attention, they put a dot right there. Everybody does it. And then they draw a horizontal line. And I'm like, no, that's not X equals 3.
so if it would be like that.
Be like this. Right here.
Alright, so that's right.
So I'm wrong.
You are absolutely wrong. It's a vertical or horizontal line, all of these. Hey, y equals 2, vertical or horizontal? Okay, so find y equals 2. Where does y equals 2?
Right there.
And what kind of line is it?
Right, horizontal.
So you draw a horizontal line, you're done.
Oh, okay, so it's easy.
Ow, my leg.
Who's lost?
Not me.
Vertical or horizontal lines, kids even in Algebra 2 make a mistake on this stuff. Hey, x equals -2, vertical or horizontal?
Horizontal.
You said both.
Horizontal.
Vertical.
I said it and you gave me a word like sorry.
X, just you gotta think the opposite.
X is
X goes like this, but the line is opposite.
X vertical.
So I find -2 on the x-axis, -2 is right there, and I draw a vertical line. You're supposed to stop me if you're lost.
No, that's
I already did them.
You should have, right? After you see the first 2 examples, right? Hey, vertical or horizontal, Aiden?
Horizontal.
Where's -5 on the y-axis?
On the Y, it is down 5.
Okay, so I put a dot there and I make a horizontal line. That's it.
One is
Did we have to throw in 2 points like the previous one?
No.
You don't do anything other than graph that 1 point and draw either vertical or horizontal. Last one, vertical, horizontal.
Vertical.
Now where is 0 on the x?
Oh, there's a pattern going on. It's vertical.
So this, yeah, there is. This one is the actual y-axis. Okay, here's the paradox. The y-axis is x equals 0. What's the x-axis? Y equals 0. There's your paradox, right?
What's the paradox?
A paradox are jumbo shrimp.
they're small.
So like,
You've never had jumbo shrimp before?
They're called paradox.
Paradox are 2 things that kind of
Contradict.
contradict each other in some sense.
small and big.
There's lots of paradoxes,
I am a paradox.
right? A paradox would be the fire department, you know, where they live, burning down.
That's irony.
Oh, because they're
That would be a irony paradox, right?
But they're fighters.
A paradox,
That's the thing.
It's like the Olympic swimmer drowning.
yeah, that's irony, right? A good paradox would be something to the effect of the great paradox of life is what?
Not dying.
You're born to die.
Oh. Technically, it
Don't think
depends on
about that at
the-
9 o'clock at night when you're trying to fall asleep. All right.
No, for me it's 3 in the morning.
All right. Quick note right before the bell rings. Look up here. Now, I started off this class by saying, do you need graphing paper? What was my
Yes.
answer?
No.
It's up to you. All right, look up here. For those of you that don't have graphing paper, and tonight you have to make a line, right? And let's just graph 1 point. How do you graph 2, 5 with no graphing paper?
You just
Just
don't.
make the points.
First off, you need to use something straight. your ID card, something that makes a nice straight line, straight edge. Do not do this by hand, it will not work. You got to use a straight edge. Now look at the board. I'm going to use a straight edge, and I'm going to make a x-axis and a y-axis. Yes? You can do that clearly with, some people use the edge of their notebook right here as well too. Okay? All right. I don't have to put 10,000 little tiny squares. Aiden.
Listen, you don't have to put little tiny squares.
Yeah, but you're not looking. I don't need to put 10,000 squares. I don't have to put any tick marks except for the tick marks that I need. To graph 2, 5, how many tick marks do I need?
2, 5.
2, 5.
I need 7.
Yeah, 2 and 5. 7.
Watch.
Oh,
What does this say to go? Left, right, or up and down? Stay with me. Does it say go left, right, or up and down?
right.
It says right how many?
2.
So I go right, 1, 2. Now, do you see the spacing I just had? If you're doing this by hand, the spaces need to be the same. So as soon as you put that first tick mark, you decided how big the spaces are going to be. From here, I need to do what? Go up how many?
5.
So I go up 1. Now I try to make the spaces exactly the same. 1, 2. Now I'm doing it by hand. 3, 4, 5. So I can't be perfect.
It's not going to look pretty.
If I go to where they intersect, it's probably not perfect, but it's darn close. Hey,
You're surrounding somebody's floor.
hey, please stop.
Yes.
Yeah, because last week we had.
Hey, stop, everybody. If you want the class to turn around, you got to start doing something. You show, never going to say interest, right? Some of the classes can be interesting, some of them will never be interesting, depending upon the type of person. But you got to show effort in behavior. Effort in behavior means you're listening, you're trying to do what the teacher expects you.
We were trying to.
Stop talking. E-learners, any question?
No,
You got this under control?
yeah, it's good.
Cool. Cool. See you tomorrow.
Bye.